All right, we can start. It works. Yeah, all right. So welcome. Thank you for coming. I know it's a tough spot after lunch and what's not. Yeah, we'll try to figure out what's going on with DevOps. It's been a while since DevOps is with us, but we'll see what do we know about it 20 years in. You know what, let's do something fun. Who thinks DevOps is like, it's an engineering thing? DevOps engineers do like Kubernetes stuff, this kind of stuff, right? And pipelines, CI/CD, Argo, DB, yeah, okay, good. All right, we'll see if you still think it by the end of the day, and if not, why not? Okay, we're going to talk about conspiracy theory. Hopefully we will stay somewhere here, grounded in reality, but you know, who knows, who knows. Hear me out. Ready for the conspiracy theory? Here we go. DevOps is a conspiracy by the ops people to make us, the developers, work harder. I'm going to prove to you that this is exactly what's happening. My name is Baruch Sadogursky. I'm J. Baruch everywhere on the internet, developer advocate at large, and my personal kind of history is started as a developer a long time ago, and then switched all the way to DevOps with a company you might have heard about called JFrog, and spent a couple of years in another company you might have heard about called Gradle, advocating for developer productivity. Today's talk has a lot of all three, of obviously the developer view on DevOps and also what it does to our productivity as developers. Co-author a couple of books, DevOps Tools for Java Developers, with another amazing speaker at this conference, Ishel Ruiz. I think she already did her talk. If you was there, you're in luck. If not, wait for the recording next week. And the Liquid Software, about the future of how we're going to deliver software, and we already see some of that happening today. The most important slide of this talk is this one. If you go to speaking.jbaruch, you will find there a page dedicated to this talk. It already has the slides uploaded, the video that I'm recording right now. Hopefully I'm recording. If not, I will use the organizer's video next week. All the links for everything I'm going to talk about, including the chart for the conspiracy theory, very important. And for you to remember this very simple URL, it's conveniently in the bottom of every slide, together with some social media vanity, Vox, Ticino, don't forget to mention them when you tweet or post about this talk, and J. Baruch, as I mentioned. All right. Let's get to it. So as I mentioned, a very long time ago, when I had hair, I was a Java developer. And back then, I was curious about DevOps, as everybody. It was a new thing to learn. And one of the most important sources of knowledge about DevOps used to be back then, and still is these books, the Phoenix Project. Who read the Phoenix Project? Oh, definitely not enough. So, if you need to take one thing out of this talk, is this book. If you want to learn about DevOps, this is where you go. Now, I know you heard a lot of book recommendations during the day. You will get more, even if this talk. Now, this book is different because it is fun. This is actually a novel. A non-science fiction novel, not a technical book, not like a boring diagrams and tools and code. This is a story. And it's a wonderful story that you can learn a lot about from looking at the cover. And the cover actually features all the main characters in the book, and we're going to go through those characters, and you will notice something interesting. So we'll start, we're going in the counterclockwise direction. Over there is Patty. Patty, she's director of IT service support. She works in ops, and her colleague that works with her is Wes. And Wes, he's director of distributed technology ops. Those are very important people for the organization. The organization, by the way, is a company that manufactures parts for cars, like automotive parts. And so they do, obviously, a lot of heavy lifting there. Sarah here, she's an SVP of Retail Ops. She's in sales and marketing, and she's the main antagonist. She's kind of the bad guy of the story. Steve, he is CEO, acting CIO. The story begins with how terrible everything is, and they fire their chief information officer, and then kind of the CEO steps in being interim CIO. And now there is also Dick Laundrie, who is the CFO. I don't know what he's doing. He's not that important. But now we get to Bill Palmer. Bill Palmer, he's the main protagonist. He is the person who invents DevOps and transfer and completely turns around the company from being on the brink of bankruptcy to being a very successful company using DevOps, and he is VP of IT Ops. Okay? Eric Reid, he's a board member. He's a very interesting guy. He basically read one book called The Goal by Eliyahu Goldrath, and all he does throughout the story, he throws quotes from The Goal on Bill and pushing him to invent DevOps. The whole story was like, hey, go read The Goal and now do what The Goal says, but that would be a very short story. Anyway, Brent, he is the most technical technologist of the entire company. Actually, he is the guy that maintains all the IT of the entire organization. Very, very important person, and he is a lead sysadmin. He works in ops. And there over there is the Chief Information Security Officer, Josh. John, he's hiding for a very good reason. But yeah, so what do you notice as it's now trendy to ask on social media? What do you notice? Thank you very much. There are no developers, like at all. It's a book about DevOps. There are developers in the book. There are not pictures in the best of light. Those are the people who at 5 p.m. throw the pen or the keyboard and go home because their day is over. And they stick the ops with all the hard work of actually making it work. So this is the story of DevOps kind of told from a perspective of ops people. And this is exactly how it is everywhere. Let's look at Google and see who teaches us DevOps. Right, so if you type what is DevOps in Google, you will have 350 million results, not surprisingly. And the top will be, well, Amazon, ops platform, cloud platform, Atlassian, ops company, GitLab, they have what they call like DevOps platform, DevOps in the box, whatever they call it. Microsoft, that's another ops platform, cloud platform. Who else is there? TechTarget journalists, Wikipedia, okay. Synopsys, consultancy company around DevOps. Logs.io, another observability ops platform. And IBM here also have like a cloud platform, basically ops platform. Wherever you look, the people who are passionate about DevOps are ops people. The question is why? Why ops people trying to sell us, all collective us, on DevOps? If you search for how do you become a DevOps person, you might come by this answer. as a Linux system administrator, how do I shift my career to DevOps? And there is some good advice here. Basically, they say, well, you already know Linux fundamentals. All you need to do now is learn something called Gits, and then you're good. Yeah, I mean, next thing you know, you go from salary of system administrator to a salary of a DevOps engineer, all by doing the same work as being system administrator with a little bit of Maven and Gits. And then next thing you know, there are tens of thousands of open positions for DevOps engineers, even now, with all the layoffs and what's not. And even more, there is an entire industry that profits from teaching people Gits and making them DevOps engineers. Now, this really mattering me for a reason that we will get in a second. But there is definitely money involved. And there is definitely a lot of money involved. And DevOps is a very successful venture, whatever you call it. And the question is why? Now, if you ask why enough times, you will probably become an engineering manager. We'll stop at 2 for now. So we will ask why once again. Why there is so much money in DevOps that wasn't in system management or ops? The reason is this. This is what it's called the DevOps Infinity Circle. And it goes from from plan to code to build to test, and then release, deploy, operate, monitor, and then obviously it's an infinity loop. Now, this might look familiar. Does it look familiar? It does look familiar because it looks exactly like what? What does it look like?
What we are doing in the development cycle.
The development cycle, thank you very much, is this with a tweak. They took everything we do and then they attached their own work to it. They say like, okay, you do this anyway, now go ahead and start doing that as well. And we'll call it DevOps. How cool is that? Seriously, it's exactly the same picture, just with more work for us. Another very important piece of paper in the DevOps world is Accelerate State of DevOps report. It's been running for 10 years, 11 now, and it actually captures what it says, the state of DevOps. Where are we as the industry in DevOps adoption, how well we do it, and what's not. We're going to get to it multiple times today. The first page that I want to show you is from actually an older report, but there is something very interesting here. So you can see a report of how people spend their time. And this actually looks very relevant to any of us, right? So there is a new work, and that's basically what we do, and then unplanned work and remediating security issues and working on defects identified by users and customer support work. I guess like this is, we can relate, right? It makes sense. The question is how the new work and the rest of the work is defined. And the definition of new work and everything else is actually given both in the Phoenix project and in DORA report, and it looks something like that. So we have the new work, which is business projects and new features. Looks good? Looks good. Internal projects are defined as server migrations, software updates, and so on. This is how you go, huh, interesting. And then it gets even more interesting. Changes driven by feedback on completed work. This is fine. Unplanned work are support escalations and emergency outages. Now, this is all very fascinating. There are server migrations and version upgrades and outages and all, but what exactly it has to do with us, the developers? Our work is very simple. We have new features, it's writing code. We have refactoring, it's writing code. And we have bug fixes, which is writing code. No server migrations, no emergency outages. This is ops people trying to convince us to do their work. Very clear by now, right? Okay, so let me ask you something else. If we agree that server migrations and emergency outages are not our job, what is our job? There are multiple definitions of what software development is. The one that I really like, and regardless of all kind of scandals going on around the authors and what's not, is the Manifesto of Software Craftsmanship. Again, I mean, there is some stuff going on around it, but the manifesto itself is solid. It talks about not just working software, but software of high quality, not only responding to a change by providing value, not only individuals, but community of professionals, not only customer collaboration, but productive partnerships, good stuff about us developers. If we're going to look real close and then try to break it down by what is our definition of done, we might come with a list that goes something like that. We got what they want to understand the requirements really well, and our code is good quality, it's clear, it's like whatever you call it, and it's easy to deploy. It's very important, right? We work with the ops people, we want their life to be easy, we want our code to be easy to deploy, and then it meets non-functional requirements like security and compliance and performance. This is all very important. We didn't collect any new technical debt, maybe even sold some old one. And then the tests passing and the people who are in charge of real quality are happy, which is not necessarily the same as test passed, as you know. Team lead is happy. And product owner is happy, and product owner for us developers, it's the proxy for the customer, so the customer is happy. Do you agree with this list? Yeah, solid, good. And this is our definition of done. Basically, as long as all that is done, our job is done. Well, maybe. This is a very, very old illustration of animosity between developers and testers. If you are old enough, you remember that was a hot topic of debate 15 years ago, and it was all the rage that they are against each other and what's not. Now, who agrees that that's the case? That there is animosity between developer and QA? Oh, one hand, which means no one. Okay, now, no hands, very good, very good. And I, for one, agree, there is no, right? I guess the rest of you agree that quality is important for our work, right? And testers, QA people, whoever you call them, actually help us to get better quality. We're all in it together. We do care about the quality of our product. Now, there is a catch. And the catch is definition of quality changes. Let's go back in time and look at the website of my bank, Chase, in 2017. It wasn't that long ago, it's not even 10 years, but it looks radically different from what it is today. And most importantly, what we could do with it is radically different. 10 years ago, 15 years ago, we had a website that we could do pretty much nothing. Maybe we could look at the balance, but everything that required real operation, we dragged ourselves out of our home and went to the bank branch to do something. And then, if that was the case, let's say there is a news and announcements, and 12 hours maintenance for a website to ensure quality. We're like, oh, no, whatever. I don't care, especially if it's at night. I don't care about 12 hours, my bank not being up. Now, today, this is obviously completely unacceptable, right? Me personally, I switched banks over the usability of their mobile app. What it means to have a high-quality service, either web or mobile or whatever, is now completely, radically different. So now, suddenly, not having bugs is not enough to ensure quality. Because this site probably didn't have bugs, but it wasn't a good quality by today's standards. And code quality is anyway not enough because data. Now, this is a relatively old prediction from November 2018 about annual size of global data sphere. And back then, Seagate, they do storage, so they might be biased, but predicted that as of 2025, which is today, we are going to live way in the zettabyte era. Now, what is zettabyte? If you think about big data, what units are you thinking in? What like Google or OpenAI has as a data? Petabytes, right? Petabytes is a lot. Now, you think that petabytes is a lot, but then it turns out that we are past petabytes into exabytes. And as a global community, we already passed exabytes into zettabytes. That's like 2 orders of magnitude larger than what we used to think as really big data. And in 2018, Seagate was on point. By now, we're far into zettabytes era. And one of the interesting characteristics of zettabytes era is that everybody struggles with that much data. Even the data centers, which job is to actually take care of big data, are struggling, not to mention companies that have to work with that amount of data. For the sake of our discussion of quality, what is most important is that today, in 2025, most of the companies will not be able to replicate their production environment with the data from production environment on staging. Because it's either impossible or just too important. What do people do? They give up on the staging server. The staging server, as we knew it, clone environment of our production, is dead. We might call something that is, well, probably close to what we have in production, but significantly less data as staging, but that's not what true staging used to be. True staging, which is exact copy of production, is gone. What do we do? What do we do? Fuck it, we test in production. There is an entire industry of testing in production. It's caused, like, there is a bunch of different terms for it. The industry called progressive delivery. And it's like a bunch of different stuff. The term that I really love out of those is this, blast radius. This is a remarkable term because what is blast radius? Is when a bomb goes off, what is the radius that we have casualties? Now, think about it in terms of software delivery. Progressive delivery admits that there will be casualties. And every new release is bomb going off. There is no, well, there will be no casualties, everything will be fine. No, there is no such thing. The only thing that we try to do is minimize the blast radius. Yes, people will suffer. Let's try make the suffering as small as possible. So yes, we are going to deploy bad software quality to production. What does it say about us, the developers? Back to the question, do we care about quality? Yes, we are. So the only thing we can do in order to take care of the quality of our code is being there when this bomb goes off and there are casualties and we try to minimize the blast radius. We have to be there when our code hits production and real customers actually suffer. Suddenly, welcome to Uncall. Now, this also dramatically changes of how we write software. This wonderful list that we got suddenly is not enough. Now, we need to take care of operation of software, and this is in our best interest because this is our quality. Now, devs are happy, but who are those DevOps people? What does it mean? And this is where we get back to the term DevOps engineer. And this one I need therapy to deal with because this is the hill I'm going to die on. DevOps engineers do not exist. The meaning of the term DevOps engineer makes as much sense as collaboration engineer. Because DevOps, by definition, is a collaborative practice between dev and ops, and QA, and security, and product, and everybody else. It's a collaborative practice. There is no DevOps engineer because when you create DevOps engineers, next thing you do, you put them in shiny and amazing DevOps teams. And when you created a DevOps team, you just created a new silo. When I hear a term DevOps team, I think about this. Dystopian TV show about how in a ruined and toxic world, thousands live in a giant silo. It's a perfect description of DevOps team. We just created a silo that will work independently of developers, and we have exactly the same problem of developers finish their work in 1 p.m., in 5 p.m., and then the rest of it, whose problem is it? Well, we have DevOps teams for that. Let them play with their Kubernetes toys and deploy our software to production. We don't care. So we're back to square one when we started DevOps. And next, we need to break down this silo. Okay, we have a silo of dev, and we have a silo of DevOps. How do we break them? How about we come up with a new collaborational methodology? Let's call it DevOps. We're back to square one. So yes, DevOps engineers do not exist because DevOps is about dev engineers and ops engineers and everybody else working together. So DevOps engineer is not a term. But DevOps still requires some engineering aspects which are unique to DevOps, right? Stuff like progressive delivery, the pipelines, all this Docker containers, Kubernetes stuff. Someone has to take care of that. The good news are we have the term that exists for almost 20 years, and it's called SRE, Site Reliability Engineer. And this is Seth Wargo and Louis Forjohns speaking about how SRE technically implements what needs to do to be for DevOps. The problem is, it's a terrible term. site reliability engineer. When I worked in JFrog, one day I discovered that we have a position open on our website for DevOps engineers. I had a stroke. Really, I mean, it blew my mind. I went to the hiring manager, and I'm like, dude, what the fuck? DevOps engineers do not exist. We are a DevOps company. We need to understand that better than everybody. I'm giving a keynote about how DevOps engineers do not exist, and we have hiring DevOps engineers on our website. Why? And he's like, Baruch, I know your spiel, and you are 100% right. DevOps engineers do not exist. And the first thing that I published as a job was SRE, Site Reliability Engineer. And we started to look for people, and I put my recruiters to it. And then my recruiters came back to me and said, people don't want to maintain WordPress. And I'm like, what? And he's like, this is what people hear, Site Reliability Engineer. It's maintenance of the website. It's a terrible term. No one wants to be Site Reliability Engineer. The good news are, we have a solution now, and it's called Platform Engineer. And platform engineering is all the hype. It's not as hype as AI, but it's second close. It's also super popular now, and I think there was a talk today, I think it's running right now maybe, in parallel or something like that, about platform engineering and how to set up your developer portal and all this kind of stuff. Now, platform engineer, everybody wants to be platform engineer. But what is platform engineer? So if you ask Google or ChatGPT, platform engineering in DevOps, again, you will get tons of results about what is the relationship between the two and how they are connected and what's not. And then I'm like, okay, ChatGPT, tell me what is platform engineering? Platform engineering, last sentence, is process of designing, building, maintaining underlying infrastructure, including software platform systems, to create and deploy applications more efficiently. This is something that runs the infrastructure that then we can create and release our software on. This is exactly that. This is exactly the thing that we are looking for. So, back to our list. Let's fix it. Platform engineers are happy. Now, what does it mean platform engineers are happy? What our software needs to be in order to be DevOps ready, basically, right? So it should be modular, because when we have blast radius in one side of our product, the other should actually work. It should be deployable, because blast radius, hey, fix these bugs. I fixed it. It's built. Now we need to be able to deploy it very, very fast. It's observable, because we want to know that something doesn't work before people start complaining on social media. It should be scalable, because we cannot scale, like our website is slow because of all the load. Boom, we want to scale it right up. Upgradable. I have a new version with a fix. We need to deploy it right now. Downgradable. Ooh, the fix will take me 3 days. Let's undeploy the new version and work with an old one, but then the old one should work with the new other services. So this is a lot of stuff that needs to be supported, right? Clear deployment plan. Because at 3 a.m. you don't want to start digging for the dogs of how to deploy your service. Stable and fast build. We need to create a new version with the fix immediately. Stateless for scalability. Fast startup and stop. The last thing you know is, the last thing you want, we have a new version. We managed to build it, and now we sit for 5 minutes waiting to get up, and, blast radius, people are suffering. Observability, we spoke about that. Feature flags, how about I just turn it off? It has a bug, this feature. I just want to turn off this feature. The button that does what it shouldn't do just disappear, which is very cool. Backwards and forwards compatible, we spoke about it. Event streaming, we want to monitor stuff. And interestingly enough, our code needs to be cheap. What does it mean, cheap? Cheap is actually writing code that will save us money. AWS bill, ops people hate it. You don't know about it, but they really do. They will never talk to you about it because what you have to do with with lowering AWS build, but you actually can. We can ask ChatGPT, how can developers reduce AWS costs? And the first answer is optimize code. We can actually write code that will benefit the entire organization by lowering ops costs. And ops people don't know about it. So now, suddenly, we have some business concerns that might be of an interest to us. So next time your boss asks, how can we cut costs? And the first answer would be layoffs or cut of benefits. Maybe not. Maybe, you know what? Serverless, cloud, lean code is the answer, and we don't need layoffs. And instead of worrying about layoffs, maybe you should worry about how to get into Kubernetes and learn how to lower the AWS build. And you know what? Business loves DevOps for another reason. And this is happy customers. Those are the customers, and they want new features. When do they want new features? Yesterday, obviously, right? This is what DevOps promises. Back to State of DevOps report. This is all backed by scientific research. Top performers or elite performers release 127 times faster. This is how faster you can be than your competitor in putting new features to the market. And Abed said, hey, we need AI features right now, like yesterday, everybody do AI, we need to do AI as well. This is the answer. DevOps, how fast can you plug the chatbot into your help pop-up button? This is what it means to add AI to our software, right? This is how fast you can get it to production. So the problem is DevOps is good for business. And even if it means that we feel like we've been taken advantage of and need to do more work now, unfortunately, we have no choice. Business likes it. It's good for business. It means that we have to do it. And it's a natural evolution. If you think about it, the ideas of DevOps are direct continuation of other ideas of our industry. For example, Agile. Or, if we go back to other industries, I already mentioned the book, The Goal. It was about theory of constraints in manufacturing. DevOps does what theory of constraints done to manufacturing to IT. So it's a really evolution, and it might have been an ops idea, but we have to run with it, right? It provides business real value, and you need to be on board or you will be off the ship. AI can help a lot. Today, we are in an amazing time, and if you've been to Stefan's keynote, you know exactly what I'm talking about. You can provide real value to your ops partners and to the business by learning, by closing the gap of with them really, really fast thinking AI. And if you use AI for your developer work, you understand how easy it will be to use it for everything else. And the questions of how can I optimize my code to make it leaner, to save the ops people money on AWS build, think what it will do to your career if you have those conversations with your ops peer. If you come to those platform engineers and say, I think I can lower our cloud consumption in 20%. You will be their favorite person in all world. And this is now very easy to do thanks to AI. With that, thank you very much. I have 5 minutes for questions, if I understand correctly. And as I mentioned, I'm at JBaruch everywhere. This is Vox Ticino, and you go to speaking.jbaruch for the slides, the video, all the links. Thank you.